Welcome to the C2 Smarter Fueling Innovation Industry View on CV Data and Applications Fireside Chat. My name is Haggai Davis, and I am the moderator, and I'm joined by Chris Wichman.
Good afternoon, everyone. Thank you for having me here. My name is Chris Wichman, and I am a Transportation Solutions Advisor, which is a big long name. But what I do with AirSage as a company, I talk to our clients, our customers who want to leverage big data, mobility data for various applications. So today we're going to talk about connected vehicle data, and I appreciate the invitation to be here to talk about this. Another area of big data that we work in is these things, the smartphone big data. So you think about, we're going to get into some of the use cases and also limitations of connected vehicle data. One of the limitations is I made a trip here today without riding in a vehicle. So we have to always be cognizant of what connected vehicle data is actually observing, which is vehicles on the roadway. So that's what we're going to dig into. Before we go to the questions, I talked with Janie before about maybe some kind of level setting or definition setting, background type information I could share at the outset, just so we all kind of are talking about the same thing. So AirSage as a company, what I mean by connected vehicle data is really purely passively collected observations from an onboard system installed in a vehicle. So there's really, to me, 5 core attributes that we're receiving from these connected vehicles. And that's the geographic coordinates, so the lat long of where the vehicle is, the heading, what direction the vehicle is going, the speed that the vehicle is traveling, and the timestamp of that observation. And then the final very important attribute of connected vehicle data, in the way that we use it, is a vehicle identifier that can be used to gain some insights into chaining these points together to understand a trip. So for this, CV data to me is observation from a vehicle that's being reported to some central system, to the cloud. It's being stored, and on the back end is accessible to us as practitioners and as researchers, for our work. So I'm not here talking about where vehicles are communicating with one another. This is not vehicle-to-vehicle communication or vehicle-to-infrastructure or Bluetooth type collection. This is purely an onboard system in the vehicle that's reporting out those core attributes. There are some other things that we can learn from connected vehicle data. Obviously, if you've been in a connected vehicle, you know that there are certain warnings that you can receive, lane departure, and different things that are also interesting attributes of connected vehicles. So that's my definition of what is a connected vehicle. But it's really important, and actually we were just discussing this prior to this session, is that there are kind of multiple channels from which this data is collected. So I just to kind of describe 2 channels and compare and contrast them. So one is essentially the Wagyu beef of connected vehicle data, the very high quality, high granularity data that comes to us from the vehicle manufacturers themselves. So this would be what we call OEM, which is original equipment manufacturer, OEM grade CV data. So this is from onboard systems that are in the vehicles when they roll off the manufacturing line. So you all are likely aware of who the vehicle manufacturers are. There are only dozens of them in the U.S. and throughout the world, less than 100 vehicle manufacturers. So that's one channel that newer makes and models of vehicles across manufacturers are coming out with some onboard system that's reporting these data elements. So think 2015 and later model year vehicles. So that's one channel, and the real benefit of that data is it's very high granularity. There's a lot. It's very representative in that it's covering a broad cross section of autos that are on the roadway. So then the other channel that I'd like to describe here as part of the definitions is what we refer to as telematics service provider, or often fleet management type data. That's some device that's being installed in a vehicle aftermarket. So this would be, think of truck fleets or commercial fleets that the operator of those trucks need to know where their drivers are at any time to do scheduling or just to understand the operations of their business. So the TSP data set, it covers trucks, cars. The car type use cases would be for insurance or rental cars, for private autos. So this TSP data set is much more diverse in including different vehicle classifications. But in terms of the granularity or the observational rate, we're typically seeing about a 15, 30 to 60 second reporting rate from these vehicles. So just thinking about the use cases that could be available to you through OEM data in comparison to TSP data. So both of these sources are very rich and important to the things that we do, and I know we're going to talk in questions a lot about the applications of the data. So I do want to make sure at the outset, not only to set definitions, but then also give a little bit of a kind of a step back and view of where the industry is. So with connected vehicle data, we've really only been working with it for just over a decade or so, 10 to 15 years that we've had access to this data. And over the last few years, there have been some companies operating this space that served a really important role of aggregating this data from the vehicle manufacturers. In calendar year 2023, I would say this space was marked by a lot of disruption. There were multiple companies that were serving in this aggregator role who went out of business, which really kind of cut the flow of the high quality data, accessible to you as researchers, accessible to us as insight providers and practitioners in transportation planning and engineering. Some of that's starting to stabilize and come back to market, but I think that's one of the nearer term challenges is how do we sort of bring this data from the servers that are within the vehicle manufacturers and bring it into our environment where we can really help drive decision making, drive policy making, drive safety improvements, and different things that we can do as practitioners and researchers when leveraging this data. So that's kind of the few thoughts I wanted to start with before digging into the questions is just kind of the state of where things are and defining what I mean by connected vehicle data.
Yeah, and so also if at any point in time there's questions from the audience, this is very much supposed to be interactive. I have questions, I'll be moderating, but please, feel free to contribute. So the first thing that just jumps out about what you said is that you actually mentioned that there's a lot of disruption and that one of the major data aggregators went out of business. One theme that I like to track across a lot of different fields is the business model. I would actually would have guessed that this would be a relatively stable and profitable industry. And so I'm curious, why did they go out of business? And then what are the things that people have learned and how has the business model changed from that? Because I think the ways in which people make money off of data collection and data distribution informs a lot of different aspects about it.
Yeah, I think as an industry view, this is so new, right? There's typically in any new industry or new technology, there's some early failures and there's some companies that emerge out of those failures and learn from that. I would say in this particular case, the end user community or the buyers of this type of data, me as a former practitioner and DOT employee, I was still in the phase of learning about the data, learning how it can be used or the use cases. It hasn't been as evolved to where maybe the buyers were confident in purchasing the data. Now they needed to investigate and learn a little bit more when the business model or the companies in question needed to have buyers immediately to make themselves profitable. So maybe there was a mismatch between the readiness of the company to really provide this valuable service and this valuable data stream into our industry, a mismatch between that and the end user community. As we're learning more, and we're learning more just in discussing with folks like those here at C2 Smarter, the things that we can do with this data. I think it's just an evolution. I've always thought we're really in the infancy of this data. it's only going to grow in its penetration rate and what we have available to us, and how we can apply it is only growing. But we're really kind of at the beginning, and the business model, as there's more adoption, the business model will sort of take care of itself.
That makes sense. And so you mentioned that part of it is figuring out who the users are, what their use cases are. Who are some of the more interesting users of this data, and then how are you seeing them use it in interesting ways?
Yeah, that's the kind of coolest thing about my job is that I'm fielding calls, talking with DOTs, NPOs, metropolitan planning organizations, cities, various folks in academia who want to leverage this data, and I can help describe it to them, and also ask questions to them about what questions are they trying to ask of the data, what problems are they trying to solve. So there are a lot of things emerging in the safety space. We were just discussing a project leveraging connected vehicle events data, which is sort of separate from what I've discussed before. This is really where you have some harsh braking or harsh acceleration event that's or observation of one of those events from a vehicle. So the safety type use cases. I know for this center in particular, some of the operational type use cases, which really do require that more granular OEM data to do things like signal timing coordination or understanding queue length and queue length detection and things like that using purely passive data. So I think the opportunities are endless in terms of within transportation planning and engineering, the things that we do. I feel like CV data can be applicable in almost all cases. It's just a matter of fitting the right data set to the problem. And also the consideration that I mentioned before. Again, I didn't enter a vehicle on my trip here. So to understand the generalized movements of people, connected vehicle data is not a silver bullet for that. You really need other data sets to complement for person movement.
You mentioned a little bit about there is event data like harsh braking. I know in the past there have been data sets that included basic safety messages. They included things like wiper status. Are those like variety of data types also things that you guys collect, or is it much more focusing on truly the basics of direction, speed, heading, location, things like that?
Yeah, I think variety is a good word, and that's actually one of the points that I wanted to make sure to emphasize here, is that because the channels with which this data is collected is independent vehicle manufacturers, independent TSP operators, they all have different needs and reasons to be collecting this data. And right now where we are, there is a variety because there's no standardization. There's no ISO standards for how connected vehicle data should be collected and what it should include. So in that way, the variety can be a challenge to overcome in sort of pulling data from various sources together. You all probably worked with matching attributes from one data set to the other. These sorts of challenges I think are definitely something that we work through as a company on behalf of our clients, and it's something that will maybe require some discussion between the various points of observations. The different companies kind of come together and say, okay, what are we going to define as our standards for harsh braking events? Because if they're all different, then it's hard for an end user or practitioner to really know how to glean the insights from that. If you're looking at 10 different data sets, are the events all capturing different things?
So do you guys do your own analysis on the data? And then if you are doing some analysis on it, what tools do you have in place to aid that process?
Yeah, so as a company, how we operate, we are a data provider and we're not a consulting firm. So a lot of times when it comes to kind of gleaning the meaningful message from the data, we are partnering in some cases with engineers and planners with their particular use case. We do some back office type analysis just to understand what we have. We do, one of our big, where we spend a lot of our time is really in the cleanse and refinement process. And that's particularly for this mobile device data, which can be very messy, cleansing out and deduplicating devices and things like that. With the vehicle side, the data is typically more clean, but it's a point-based data set, so we're finding a lot of our end users are relying on us to do things like conflating to a roadway network, to make analysis at the segment level or intersection level more streamlined for them. So those types of back office type pre-processing activities is really where we focus.
That's interesting. Whenever you have all this data, you mentioned that different people ask for it in different ways. Is there a challenge in how you store it? Is it all just saved in a large data lake essentially? What tools are you guys developing to make accessing it for us as the end user more efficient, more intuitive, things like that?
Yeah, so this is kind of the biggest challenge with connected vehicle data. Just to kind of demonstrate this in kind of an anecdote is, if I drove to my office and it's a 20-minute trip and my vehicle is reporting every 3 seconds, that's 600 records to capture. 600 records is able to capture one trip for me going to the office, and I'm one person, and that's one trip. So you think about the quantity of the data that's being generated by these connected vehicles, and again, where we are now, if we're only at the high end, maybe 20% penetration of all the vehicles on the roadway, the quantity of this data is only going to grow and grow over time. So really, thinking about what this group can focus on is like, how do you make big data smaller, and how do you store, process, access the data in a way that's not overwhelming. So that's one of the challenges, especially for small agencies or even DOTs that don't have a lot of technical staff that can just dedicate their whole job description to processing CV data. That's really where we come in and help them curate the data down to maybe the month that they're most interested in, the representative month of data, rather than providing multiple years of data and all roadways. It's a month of data on a particular set of links that you're interested in studying. So that's, I think, a value add that's an important role when you think about the public agencies. I would assume in the research community, you all just want the biggest lake of data possible, so that you can do a lot of that independently. But it's definitely something that is a challenge now, is storage, accessing the data, the costs associated with that too. You think about AWS costs, cloud computing costs. Those things all factor into how we operate our business.
One of the things which I find useful is having like a case study or some way to visualize or see what are the applications of this. Are there specific projects that you're working on right now, specific collaborations with end users that you think would be interesting as an illustrative example?
Yeah, a couple of the projects that we have underway now, I mentioned kind of the safety events examples. So that one is really of interest right now in the again, agency and user space, trying to understand with our safety action planning that are going on all around the country is how can we leverage this data, which is different than crashes, right? Because with harsh braking, harsh acceleration, this is really kind of a risk measure rather than outcome measure. With crashes, you can observe that they took place, but you aren't getting insight into where maybe they could have taken place. So I'd say that's one that we're really focusing a lot of energy and interest in. And we're getting a lot of positive feedback on how event data, harsh braking, harsh acceleration, cornering is correlating to some of the other factors in the roadway characteristics. So that one's interesting. A cool one that we're doing now in the city of Baltimore, they have along I-83, which is one interstate segment that runs through Baltimore City. It's about an 8-mile corridor, 7 or 8 mile corridor, and they've installed a video enforcement camera at the midpoint of the corridor. And what they were finding, anecdotally or kind of seeing is, speeds remained high, as they approached the camera. Drivers sort of got wise to the camera being there and would start to slow down, in proximity to the enforcement ahead sign and the camera itself, and then speed back up. So the idea is, what's being borne out in the data, And is this an appropriate countermeasure if driver behavior is essentially evading the countermeasure? So with the traditional speed data that we've had at the link level and averages, link level averages, you can't drill in to really understand what did this particular vehicle do point by point as it transited the corridor. So that's really thinking about this data in its disaggregate sense. You have some proxy for what that driver is doing and how they were interacting with the corridor and the sign in the camera for video enforcement. So things like that where you can leverage the capabilities of this disaggregated data, I think are most interesting.
Very cool. One of the things as a researcher that I'm always interested in is how can you pair data sets together? What are the type of data sets that already exist that CV data complement well?
Yeah, so one of the things that often comes up with CV data, and one of the points I wanted to make sure to hit on, this obviously is an area of much privacy consciousness. We need to make sure that we're anonymizing the data well. So part of what's helpful as a practitioner is to be able to chain the same set of trips from a vehicle together to understand the trips over a course of days, to understand maybe why these trips are being made. So we have that ability with our mobile device data to infer a home location of the smartphone because we have a persistent ID associated with the smartphone. So that allows us for OD to really understand home location of the device, work location of the device on an inferred basis, and understand from that the trip purpose. Is this a home-based work trip, home-based other trip? Kind of the things that we need for travel demand modeling to understand trip purpose. So the same capability does not exist with connected vehicle data because we have essentially a reset of the ID with each start of the ignition. So that's one limitation of connected vehicle data for things like long pattern OD. You can get a trip OD, right? Where the trip generally started and ended for that trip, but you can't associate that to a generalized view of all the trips occurring for that individual. So in some way, I think complementary-wise, we're viewing the OD data we can provide from the cell phone, smartphones as being a good complement to the connected vehicle data. This thing is not good at telling you how fast someone is traveling or the speed, and CV data is great at doing that. So there are these kind of different types of probes that are around us in the world. We have the cell phone as a probe, and the vehicles themselves as a probe, and they have kind of these complementary characteristics of one another. But in terms of more traditional data sets, I would say anything that's being measured by hardware, roadway characteristics, anything we traditionally would leverage in planning and engineering, I think couples well with the CV data.
Very interesting. So you said that right now your end users are mostly government agencies, or maybe they're researchers. Are there specific groups of people who you don't envision as your end users, people who you just think either they wouldn't want this type of data or maybe you wouldn't sell it to them?
Well, I mean, I guess there are a lot of people who probably wouldn't want this type of data, right? It's kind of we're in a specialized group here as transportation professionals, but I would say that the approachability of the data, in its kind of raw form, it's not that approachable if you don't know how to do some work in Python or R or some advanced scripting capabilities to actually understand what's in the data. So I would say we probably for the raw data use cases, we're probably dealing with users who are a little more savvy in terms of their technical capabilities. There are lots of ways to overcome that by providing tools and visualizations of the data, which we often work on to make sure that the data is accessible to a broader swath of users. In terms of use cases that we wouldn't support, again, we're very conscious of a lot of the privacy implications of these things. So we definitely, at the outset of a project, talk about what's this data going to be used for. There's typically we haven't had nefarious use cases emerge, but in that case, we would definitely deny service to any type of nefarious use case. And that's really one of the other important points is like the anonymization of this data. We're doing a lot to understand, kind of truncating trips to, rather than be like a driveway to driveway type of output, that we're truncating trips to some natural, maybe zone, like think about it from the modeling perspective, like a traffic analysis zone. Maybe we truncate the trip to the edge of the zone to the endpoint. Again, as a privacy measure, not providing the driveway start point of a trip, but in some way either conflating it to the first roadway point or the edge of a zone associated with that trip. So that's, I think, a safeguard that we're very serious about, and I think is important to, making sure that this data doesn't go away, because, as you can imagine, if there's some scandal or some, big upheaval or some story in the New York Times about the use of connected vehicle data, that would be detrimental to our industry and all those in academia and research and the agencies who want to leverage the data.
I appreciate that you guys are very thoughtful about that. Those are absolutely concerns that I share, is the fact that you are thinking about that, you're working towards that, makes me feel much more comfortable using this and makes me feel much more comfortable that it will continue to be around for a while. In 5 to 10 years, if this is very successful, what are new trends or what are new applications that you see emerging from this that maybe are in their infancy right now?
Yeah, and I think one of the things you all are working on is AI, machine learning. I know that's one of the big hot topics. I was at TRB this year, and it seemed like every session that had AI or machine learning in the title or description was flowing out into the hallway. So it's hard for me to project forward, where things may be headed in that sense. But the way we're kind of thinking about it is twofold. Big data is good training data. So CV data, training sorts of models that can be developed, as well as like the idea that, and this is just something I've been thinking a little bit about, is the ability to generate synthetic CV data. I know that the synthetic data is becoming more popular. You're even seeing the federal government doing more with that, with like survey data, doing synthetic views of the survey data. So if there's some way for the CV data to create new CV data that's representative of movement, that could be kind of an interesting kind of future ahead of us, where you have a training data set that can help inform typical behaviors and be generative of more data. So those are just some things I've thought a little bit about. As far as like the regulatory side, there's really no way for me to project where that could all go. I think right now the regulations are kind of set. We're not hearing as much about regulations in this space, but as more connected vehicles are coming online, there may be more emphasis on that. But again, that's really hard for me in my role, not being in DC and not being, understanding what sort of policies are being considered or contemplated out there. That's really hard to project.
One of the things you mentioned early on was that your trip here did not actually involve a vehicle. And so I would imagine that New York City is an outlier in a lot of ways, and that's just generally true. But are there other regional differences that you see? Maybe the South uses vehicles or connected vehicles differently than the West or the Midwest?
Yeah, we've looked at this a lot. Like one of the best proxies for penetration or quantity of data is really just, it's correlated to volumes on the roadway. But there are some regional differences in the adoption of newer vehicles. This is becoming a little less of an issue as post like 2015, 2016 model years are kind of becoming used cars and are kind of migrating down the cost scale to acquire those vehicles. So you're getting better representation across socioeconomic groups as the CV data or CVs are more widely adopted. So some of those representative questions are going away. We have looked at, like, in rural areas, there have been questions about, okay, well, we don't have newer vehicles out here. Everyone's got an old farm truck. But one of the things that you'll find is a lot of the old farm trucks are actually new farm trucks, and you have like good penetration in some rural areas because of newer model age vehicles for work trucks and things like that. So some of that's going away. It's really hard to give a global answer to that because it can be very, let's look at your study area and determine what penetration we have here. Because it could be in some areas 10% or greater, in some areas down to 1%. It just, it can vary.
At what threshold do you start to feel comfortable about your data? Is there not one singular threshold, is more a confidence range?
Yeah, I mean, it depends on the project, what's it being used for. So, speed data, as many observations as you can get are good, but what can you do to supplement that? You can extend the study period temporally so that you're collecting more observations over time. So there are ways to kind of make up for the difference in just your study design and make up for some of the, on a daily basis, you may have a different level of penetration, but if you're doing some of these nuanced ways of designing your study, you kind of overcome that. There probably are use cases that we would say this isn't going to support that use case. Like if you have something very operational and you don't have a penetration rate to determine signal performance or something from connected vehicle data, then we wouldn't support that type of project. So it's definitely a case-by-case basis.
Interesting. So another one of the big fields that we are interested in is environmental data. And so ways in which we can reduce emissions, ways in which we can reduce pollutions. What can CD data tell us about those quantities, and how can we leverage CD data to improve on those targets?
Yeah, we've had some interesting conversations around greenhouse gas emissions and understanding like make and model of vehicles and driver behavior and trying to kind of quantify. The issue is, again, the inability to kind of chain trips over time and to do kind of this generalized OD. So for understanding like how people are moving generally, we often steer more towards the mobile device data, where you can kind of understand in the bigger picture the overall movement of people. We've been discussing recently with a university a use case where they want to tie together vehicle registration data and understanding average makes and model year as a proxy for emissions generated from those vehicles. Tie that to our OD data to kind of understand are there different travel patterns for zones that have a vehicle registrations that are typified by higher emitting vehicles. How are they traveling differently than zones that are typified by more fuel efficient vehicles and things like that? So there are a lot of interesting ways. I think it would just depend on what the question is that you're trying to address.
You said that right now our thresholds are between 1% and 10%, depending upon your zone. What is the main barrier to those increasing? Is it just over time as vehicles renew and enter the market, then we will see that number go up? Or are there major hurdles somewhere that we need to overcome to have it get more towards a 50% number or a 75% number?
Yeah, and I think some of it comes back to my earlier remarks about, there's a lot of different channels that this data is coming from. So if you think about each channel kind of leading to its own data lake or data silo, if you sort of combine all those silos together, you're probably closer to like 30+% penetration rate, on the roadways. But the issue that we're facing is, with these silos, some manufacturers don't make their data available at all, so they would be sort of excluded, from that top line 30+%. So I would say to achieve those higher rates of penetration, again, there's going to have to be some resolution to the siloing effect. So these observations are coming through various channels. How do we kind of bring them all together so we get the big picture view of the vehicles on the roadway? I don't know who or how that's going to be tackled, but I think that's the way, if you want as an end user to have access to the ultimate amount of data possible, that's the challenge to overcome. But the the question that we often ask is, do you need that much data? It's nice to have as much as you can get, but do you need that much to answer the question at hand? So I think that's some of the kind of trade-off and understanding of how much data is needed to support your use case relative to what we can access.
So then it might not even be a necessary outcome that we get to that highest level of data penetration.
I would leave that to you all to to define. But I mean, ultimately, our objective is to, again, help inform this planning, engineering, decision making. You can obviously overbuild, to your study, overbuild the amount of data that you need to do your study. But what's the minimum amount of data to actually help you make the decision? So that's just some kind of trade-off, and I don't know that I have a good answer to it right now, but it's definitely something that you all can be thinking about is how much data do we need, what penetration rate do we need to be able to do all these different types of studies.
If we are thinking about using this data, I think there are a lot of people in here who are Python users, who are users and could actually access that raw data.
Yep.
How would we go about doing that?
Well, how we typically provide our data sets, and I'm trying to think of the biggest one I've seen. I think we've talked, Janie, about some high penetration data for one region, and I think that was maybe a region of a couple million people, and that was 3 terabytes of data, something like that. So this is massive data sets. I think that was one region for 1 month, and it was like 3 terabytes of data. So again, it's not just the ability to write the scripts, it's the ability to have it stored somewhere and accessible to you. But how we're providing the data sets is we deliver them as typically a CSV file that has every record, and these files can be massive, and again, it requires end users who know what they can do with that. The last thing we would want is to have a procurement from a public agency. They get the data and then they're like, oh man, we can't use this. We can't even open the file or something. We don't have anywhere to store this. There was an interesting anecdote. I forget the university. It might have been the University of Alabama, but they purchased some high resolution data from Ouija, and I think it was statewide for Alabama for some period of time. And the moment they put it on their server, the professor was like he immediately became the highest user of data storage of the entire university, and his data storage was something like 20% of the entire university's data storage for the one data set hitting his server. You guys may have heard this story before, I don't know. But it was just a real stark anecdote to know that before C2 Smarter acquires this type of data, make sure you have a place to put it and to access it for the use. So.
Actually, I have a question or more comments on that, because I know we've been talking about lack of data right now. We've been talking about making some synthetic data out of the limited data that we have. But I think just add to what Chris said, of course, as a researcher, as I said, we want high granularity of the data for analysis purpose, especially if it is safety analysis. But I was also thinking about looking into the future when we hit 80% market penetration rate or 100% in the future. There might be a way that we need to think about resampling back those data. You might not need 200% of data for operational purpose. Yeah. And at that point, maybe we will have to start to think about strategies of how to, as I said, use the best data for operational purpose, or even strategically sampling, at maybe time domain or even location domain for that purpose. I think that will be some interesting question when we hit certain level of MPRA.
Yeah, I think definitely that's one of the questions which my mind goes to next is, okay, if you can produce terabytes, double-digit terabytes of data, that's far too much for any one person to digest. And so then the question is, what tools can we make available so that that's more navigable? How can we mediate that so it's not just infinite amounts of data, but the right amount of useful data? How do you strike that balance?
I mean, that's the biggest question that we're faced with, so I don't know if that was a question to me or just a question to the ether. Hopefully it was a question to the ether, but maybe some folks in this room can help figure that out.
Well, I think obviously it's going to depend on project to project, but I think maybe AirSage can have like a lessons learned, or maybe they can have trainings or introductions, ways in which people can, whenever they query data, making sure that's, because like my first thought would just be to ask for all of it, and obviously that's just not possible. So then what are ways in which I can start to make decisions for myself as a user so that I can ask smarter questions about how much data do I actually need?
Yeah, I mean, those conversations are where we start, is making sure that we're right-sizing the solution to the question. So I mean, it would be easy for me to have someone come and say, oh, well, I'm studying Richmond, Virginia, and I need data for Richmond, Virginia, and I can say, okay, well, I can send you a year's worth of data for the whole region, here you go. But that's not how we operate. We really dig in and understand, well, what are you studying? In this case, maybe they're studying just the interstates in Richmond, Virginia, in which case we can curate the data down. So that's one of the things I mentioned. Curation of the data is a big role that we play, as well as conflating it to roadway networks as a pre-processing step, so that when the end user receives it, they can do descriptives on segments or intersections, rather than having to sort of match the data in that way. So kind of making the deliverables that we produce easy to use for the purpose of the deliverable, I think is really the role that we're functioning in. As far as, once it's on your server, how you're storing it, how you're accessing it, how you're working with it, that's a little bit, that's a little outside of what we work on, but it's definitely something that's of interest.
One of the projects that we have here at C2 Smarter is actually the Student Learning Hub. And so that's a thing that we do wherever students, it's student-led, and they will go out and do a project and then take their learnings and turn it into an hour-long presentation. And I think that something like that with data like this would be fantastic, because I think one of the places that we as researchers run into is that getting your first step into a data set, understanding where is it, how do I access it, what is inside of it, all those questions. Maybe you've heard of AirSage, but maybe we don't know all the things it can provide to us. And so having something like that which provides that middle step, which is a bit more of that hook as to, oh, here's how I can use that directly in my project, I think that would be very instrumental in accelerating the adoption of it. Yes.
I have a question. It's not really a question, but you talked a lot about your data, but you definitely know that you're not the only game in the field, so this is a chance for you to brag a little bit about why is AirSage based on the experience of some of the things we do with you.
Yeah, some of the, I guess, differentiators we talk a lot about are, I guess we were one of the first to do this, which lends itself to our credibility in understanding how to work with big data for mobility use cases. So where we started, I didn't mention this at the beginning, where we started as a company was actually taking the early cell phone data, so think like the Nokia flip phones with the game Snake on the phone. If you remember those early generation cell phones, taking that data that was really being generated by triangulation to the tower, so true wireless carrier data, and generating OD insights from that. So that's really where we started and have been evolving with the industry into smartphone app data and CV data. So I think some of that experience that we have in navigating this over a long period of time and the credibility there, I think is one of the things that we often point to. As far as our ability to access the best data, I mentioned there are all these different silos, and we have access to certain silos, and others have access to maybe the same or different silos. So that's one thing we mentioned. How do you ask good questions? When you're talking to these data vendors, really honing in on what it is that you're providing, where's it coming from and those sorts of things. So I think our transparency and kind of hand-holding folks to understanding what we have to offer is another benefit in working with us. So beyond that, not to brag personally, but we actually have folks who have worked in transportation. So my former experience is in the world of DOT in Virginia. So Virginia DOT is one of the places I've worked in the past. So we have people that kind of have worked on the use cases, applications, and kind of can help educate the clients on what you can do. So those are a few of the things that we think set us apart. But ultimately, it's all data, right? It's just a matter of who you choose to work with to get access to it and that sort of thing.
You mentioned that,
I have a question, and first thanks for the information.
Yeah.
Besides data on individual cars, do you also collect data about the overall state of traffic, like spacing between vehicles or density data on different segments of the road or something like that?
Yeah, so kind of I've been focused mainly on the raw data or the observations. The next step is, what are the analytics that you can do from this data? So things like vehicle spacing, that type of use case is difficult again because of the penetration. You'd have to have visibility of not only the one vehicle, but the vehicles around that vehicle. So that's, at this point, a use case that's not well supported. But as you mentioned, as penetration rates grow, we can start seeing how vehicles are interacting with one another as we have more of them as part of the sample. So the analytics side, we can do things like travel time and average speeds, standard deviations of speeds, the kind of typical travel time and speed analytics from CV data. The ability to do things like estimating volumes is another kind of use case. So you have a sample, and then you're essentially expanding that sample to represent all the volume on the roadway. So there's kind of mixed results you've probably seen in the literature of how well that's been done. So volume estimation, turning movement count estimation. So again, the higher the penetration rates you can achieve, the more accuracy you're going to have in doing those estimation type activities.
So 15 years ago, it was, the old cell phone hitting wireless towers and getting wireless carrier data. Now it's smartphones. 15 years from now, what will the next data source be?
Ooh, that's interesting.
Good question.
How does AirSage keep evolving?
Well, I guess it'll be the Neuralink chips are reporting out the high granularity travel data. No, it's hard to project forward. I mean, the easiest thing to answer that would be just better resolution or better penetration of CV data. And again, the thing that, I'm not an advocate, but the thing that I would advocate for is some standardization and again, removal of the silos. We've talked about this concept of connected vehicle data for all. The idea that it's more accessible to get to these data sets and the insights that you can glean from them. So that could be an interesting road that we go down. There's also, and I haven't mentioned this yet, but there's also some discussions, you may find this like in articles out there around what's your data worth to you, right? If you are the pro by driving your vehicle or carrying your cell phone, is there some compensatory or compensation that you should be seeking for your data being collected? So I haven't seen that gain a lot of traction, but it's as people are becoming more aware that they carry a probe with them and they drive a probe, there may be some more asks that they're in some way compensated for that. So there's a concept out there called the data dividend, which you can probably search around for. But things like that may gain hold in the next 15 years, so we'll just see.
I guess in Europe, they have the general data privacy regulations. We don't have any data privacy regulations here in the US, but if there were some of those types of requirements, users would be able to opt out
Yep.
or would be required to be compensated. How would that affect the model? Would it still mostly work? Do you think that would be still functioning, or would that be a major devastation to the way in which we currently collect data?
Yeah, well, I think it's, there's either a carrot or a stick, right, to incentivize opting in. So right now, I'm not certain on this, but we do have CCPA in California, which is really the standard by which we operate throughout the country. And I think, I don't want to project for any other companies, but I would assume folks in this space are operating under CCPA. So now, when you have your vehicle, if you're to opt out of storing or collecting this data, you're going to be hit with the stick of not having all the services or features of the vehicle supported to you. Maybe your navigation system no longer works and things like that. Maybe more optimally to have higher rates of opt-in, concepts like the data dividend or those sorts of things. Not only would you have access to your navigation, but you may get a check for 37 cents every couple months or something. So again, you mentioned business model before. I don't know what the business model would look like for something like that. But definitely erring towards more opt-in with a carrot versus opt-in with a stick.
That's interesting that for the individual person, your data dividend would likely be very small, but at the aggregate level it becomes much more valuable. How do we balance that fact that individual data is not worthless, but worth much less, versus once you can start to get to certain thresholds, you're able to see those larger patterns, and the fact that you don't need that 100% data penetration, you maybe only need 20%, but that is that point wherever you start to be able to understand larger movements. How do we understand the relationship of the individual to the whole?
Yeah, this is a good research question, and I think you guys have an entrepreneurial incubator here too. So maybe there's a startup that can be born out of this concept. But like I mentioned before, with the TSP channel of data, this is a device that's installed in a vehicle. So you could see this data dividend concept extending to that sort of device where you can install it in your vehicle and you can opt in to having your speed collected and potentially go through that channel as well.
Now that you mention it, the insurance companies have the view, and so in that way, your data dividend isn't necessarily the check for the value of the data, it is the fact that your insurance company will charge you less because they know that you're now safer.
Yeah.
And so are they one of your silos, or are they very protective of their data?
So the insurance company, I can't speak for all the different insurance companies that are operating in that space, but they would fall within the channel that I mentioned as TSPs, because that's some device, whether it's a kind of a dongle or plug-in that goes into the OBD2 port in the vehicle, or some other. We don't work with mobile device data, so anything that's, or I should say, we don't work with mobile device data for connected vehicle, because some insurance companies will have you install an app on your phone, and then that becomes the probe. That's a little less reliable, because your phone could fall over, different things could happen. So the insurance type data that funnels to us would be from a device that's installed in the vehicle itself.
Very cool. Are there any last pieces of advice that you have for students here who are interested in this type of data or interested in this field?
Well, advice, I may not be in a good position to advise you all, but I would say it's an exciting field, it's an exciting time in the field, it's early stages. So if you're interested in transportation, if you're interested in data science, I think there's going to be a lot of opportunities in that space. There's some merging that I'm viewing, there's some merger between traditional planning, engineering, and data science. They're all kind of coming together. So I would just be hopeful, or just be optimistic, I guess, about the prospects within this space, whether it be in research or in private industry. I think there's going to be a lot to be done, a lot of challenges to tackle.
All right, well, very cool. Thank you for joining us, Chris Wichman, at the C2 Smarter Fireside Chat.
Thank you for having me.